You are welcome back to this channel. So in today's class, we want to study geometric progression. So in the previous videos, we have done arithmetic progression, and we defined arithmetic progression as a list of numbers in which the consecutive terms increased or decreased by adding or subtracting a constant, and that constant is called a common difference. But in terms of geometric progression, which is GP, it is the list of numbers in which the consecutive number increased or decreased by multiplying or dividing by a constant. And that constant is called a common ratio. So that common ratio is usually denoted with small r. And the first term, as usual, is still small letter a. So if you write a sequence T1, T2, T3, so we have Tn minus 1, then Tn, that is the last term. So T1 is the first term. So to find the second term, so I told you that the first term, the consecutive term increased or decreased by multiplying by a constant, that is small letter r. So that means T1, to get T2, to get this T2, you have to multiply T1 by small letter r. So it gives you the second term. So to get the third term, you multiply the second term by r, small letter r, to give you T3. That is the third term. And so on till we get to Tn. So invariably, if A is the first term, if you want to get the second term, you multiply by small letter r. So the second term is AR. So to get the third term, you multiply by r. So we have A times r. Okay, let me write this one as A times r. So A times r. So this one gives A times r, which is the second term, times another r. So to get the next term, you multiply this one also by r. So it gives A multiplied by r, multiplied by r, multiplied by r, and so on. So generally, the nth term of GP will now be equal to the first term multiplied by the common ratio, then number of term minus 1. So nth term of GP, that is geometric progression, is equal to A multiplied by r raised to the power of n minus 1. So Tn, that is the nth term, is equal to A r n minus 1. So this one is the nth term and is still the last term. So if they ask you to find the last term, you know that the formula for last term is still the same thing with the formula for the nth term. Is equal to A r n minus 1. How to find the common ratio? Now we have the sequence T1, T2, T3, so we get to second to the last term, then the last term. If you want to find the common ratio will be T2 divided by T1. Then it's still the same thing as T3 divided by T2 till we get to second to the last. So it will be Tn, that is the last term, divided by the second to the last term. So for example, if we have 1, 2, 4, 8, and 16. Here, 16 is the last term. A is the first term. So if we want to find the common ratio, r is equal to 2 divided by 1, that is the second term, divided by the first term, is the same thing as third term divided by the second term, the same thing as fourth term divided by the third term, then fifth term, which is 16, that is the last term, divided by the second to the last term, which is the fourth term. So everything gives 2. So that is how to find common ratio. Now, in this case, for GP, you know, it's either you multiply or you divide. But for AP, it's either you add or you subtract. Example, find A, the 12th term of the sequence 128, 64, 32, and so on. B, a formula for the nth term. Now, 128, 64, 32, so. Now, the first term, which is A, is equal to 128. And the second term, which is 164. So we are yet to know whether it is AP or GP, because we were not told in the question that it's a GP or it's an AP. So the second term is 64 and the third term is 32. Now, but we know that first term is common to both GP and AP. Now, here is 128. So we need to get whether it is an AP or a GP. If it's an AP, that means the consecutive terms will be increasing by adding or subtracting. But if it is GP, it will be increasing by multiplying or dividing. Now, for this one now, the first term is 128. Now, is this one, you can see that it's decreasing. Now, do they have common difference or common ratio? Now, let's get if it is a common difference. Now, what are we going to add or subtract to common first term to give us the second term? We can see that this one is dividing. It's decreasing, it's decreasing. So now, the common difference, so we can see that this one is a GP. Now, to find the common ratios will now be equal to the second term, which is 64, divided by the first term, 128. It's the same thing as the third term, divided by the second term, and so on. So, the common ratio here, 64 divided by 128 is 1 over 2. And this one also is 1 over 2. So, that means the common ratio here is 1 over 2. Now, but they ask us to find the 12th term. So, the nth term generally is A multiplied by R, then N minus 1. So, to find the 12th term, to be equal to A multiplied by R, then 12 minus 1. So, 12th term will now be equal to the first term is 128, and the common ratio is 1 over 2, then raised to the power of 11. So the 12th term is equal to 128 multiplied by 1 raised to the power of 11 over 2 raised to the power of 11. It's the same thing. 1 over 2 raised to the power of 11 can be written as 1 raised to the power of 11 over 2 raised to the power of 11. So, 12th term will now be equal to, this one will still give us 1. So 1 times 128, 128 divided by 2 raised to the power of 11. So let's write this one also in power form. So 128, 12th term will now be equal to, put it down, be equal to 2 raised to the power of 7 divided by 2 raised to the power of 11. Now, according to law of indices, we can now say that the 12th term will be equal to 2 raised to the power of 7 minus 11. So this one will be equal to 2 raised to the power of negative 4. So 12th term will now be equal to 1 over 2 raised to the power of 4. So the 12th term will be equal to 1 over 16. B, a formula for the nth term. So the formula for nth term will be equal to a multiplied by r then raised to the power of n minus 1. So nth term will be equal to 128, that is our first term, multiplied by 1 over 2, the common ratio, everything raised to the power of negative n minus 1. So Tn, that is the nth term, will now be equal to 128 multiplied by 1 raised to the power of n minus 1 over 2 raised to the power of n minus 1. And 1 raised to the power of anything will still give us 1. So last term will now be equal to 128 times 1, 128 divided by 2 raised to the power of n minus 1. So nth term will be equal to 2 raised to the power of 7 over 2 raised to the power of n minus 1. The last term will now be equal to 2 raised to the power of 7 minus n minus 1. So the last term, nth term, or the last term, still the same thing, will now be equal to 2 raised to the power of 7 minus multiplied by plus n minus n minus multiplied by minus 1 plus 1. So last term or nth term will now be equal to 2 raised to the power of 7 plus 1 minus n. So the nth term will be equal to 2 raised to the power of 8 minus n, and that is the formula for the nth term. So therefore the formula for the nth term of this sequence is equal to 2 raised to the power of 8 minus n. So 2 raised to the power of 8 minus n. So that is the answer. So till I see you in the next class, stay safe. Thank you. Bye-bye.